Welcome to tonight's video on types of discontinuity and what it means to be continuous. First, we'll discuss the different types of discontinuity that you can see in a graph. The first one is what's called an infinite discontinuity. An infinite discontinuity is when you have a vertical asymptote. So let's say I have a vertical asymptote here at 3, x equals 3, and the graph looks something like this. All right, so what we say here is that there's an infinite discontinuity at x equals 3. So the graph is continuous on the interval from -infinity to 3 and from 3 to infinity. That's when the graph is continuous. It's broken up at x equals 3 by a vertical asymptote. That's infinite discontinuity when you have a vertical asymptote. The next type of discontinuity is what's called a jump discontinuity. And let's say that's x equals 3 there. So a jump discontinuity is when basically the graph stops and then jumps straight down and you have an open circle and then continues on in a different direction. This is considered a jump discontinuity. At x equals 3, and it's continuous on the interval of -infinity to 3 and 3 to infinity. A removable discontinuity is when you have a graph here. Here's 3. And let's say you have a graph that looks like this, and then there's a hole or open circle, and it continues on. This is what's called a removable discontinuity at x equals 3. It is continuous on the interval from -infinity to 3 and 3 to infinity. But notice it's removable because there's this one little hole. That's it. The rest is just continuous. Horizontal or diagonal gap discontinuity is when you have a graph that looks like this. Let's say this is at 1, goes like this, and then the gap, maybe till 3, then the open circle is all the way over here. So notice there's a horizontal, meaning there's space here in between, or a diagonal gap. And here, the continuity, it goes from -infinity to, sorry, this would be -1, to -1, and from 3, actually it's continuous there, meaning sorry, when you are talking about continuity, you don't need to worry about parentheses or bracket. And then from 3 to infinity. So those are the intervals that it's continuous on. So now the question is, what does continuity mean? Well, continuity means that basically a function is continuous at a point x if the graph can be drawn without lifting your pencil. So basically, a graph is continuous if you can just draw it without lifting your pencil. So now we're going to look at some graphs here and answer the following questions. All right, so basically, if you look at these graphs, we want to determine first, is it a function? And if you look here doing the vertical line test, you'll notice that it's a function. So the answer for this first one, it's a function. Second, what is the domain and range? Well, if you look here, the arrows here say that it goes on forever from left to right. There are no holes in the graph as we go along. So the domain is all real numbers. Looking at the range, well, it goes up forever, but notice there's a very bottom. The very bottom here is at when y equals -5. So the range is from -5 to infinity, and yes, you put a bracket because it includes -5. Part C, it says, when is the function continuous? Well, you look for any asymptotes, any holes, open circles, those kind of things, and there are none. This graph, if you start here, it's one continuous motion. You do not need to pick up your pencil. So this is continuous on the interval from -infinity to infinity. Now if you look at the next one, notice this does pass the vertical line test, so it is a function. Now the domain for part B, well, if you look here, as you go from x, notice x can be everything, and then when you get to -3 here, notice there's an open circle, so that means it can't be that. So basically it's from -infinity to -3. Then from -3, it keeps on going until 10, and then 10, it can't be 10, and notice it doesn't continue on here. So it just goes from -3 to 10. The range, notice this arrow means it goes up forever, but in the very bottom is at -3. So it goes from -3, or sorry, -3 right here is very bottom, and it goes from -3 to +infinity. Means it's greater than or equal to -3 for the range, because remember, range is y. All right. Part C, where is it continuous? Well, it's continuous. Notice if I start here, I don't pick up my pencil until I get to -3 for the x. We only look at the x coordinates to determine continuity. Then after -3, it keeps on going and it's continuous until 10. And then 10, it's over. So from -3 to +10 is then when it's continuous. And that's it. Then the types of discontinuity. Well, notice there's an open circle there, so there's a removable discontinuity. At x equals -3. Then there's also a removable discontinuity here at x equals 10. So there's two removable discontinuities at x equals -3 and at x equals 10. Those are two removable discontinuities. All right, so the next problem, let's do a couple more of these. The first thing you look, is it a function? And the answer to that question is yes. When you do the vertical line test, it passes. Even though there's a dot here, open circle, remember open circle means it's not there, so that's fine. It passes the vertical line test. Then it wants to know domain and range. Well, notice you go from negative infinity, and then notice there's an open circle here, but this dot fills it in on the x. Notice that's x. You keep going. There's an open circle here, but the dot fills it in, so it keeps going. So basically, the domain is all real numbers. The range, you look from the bottom of the graph here at -2, that is the bottom, and then you keep going up. Well, notice this arrow here means that it goes on forever, so that means the domain is, or the range is going to be from -2 to infinity. Then you look to see where it's continuous. It's continuous, well, from negative infinity to -2 on the x, then from -2 to +3 it's continuous, and then from +3 it goes on forever, and that is where it's continuous. The types of discontinuity, well, notice there's a jump discontinuity at x equals -2 and x equals +3. Those are the two types of jump continuity, because notice it jumps up from here to there. All right, for this next one, notice it is a function. It passes the vertical line test. The domain, notice the domain, it's all real numbers except for x equals 2. The range, notice it goes on forever down and up, so the range is all real numbers. And then it's continuous from negative infinity to +2, and then from 2 on forever. So basically the same as the domain here. And then discontinuity, since it's a vertical asymptote, we have an infinite discontinuity at x equals 2. That is an infinite discontinuity. All right, so that's our video for this evening. If you have any questions, feel free to ask in class, and have a good evening.